Alright, so the next TCP/IP network layer protocol that we're going to talk about is the Internet Protocol, commonly referred to as IP. Now, when we're talking about the network layer, we're also talking about layer 3 of the OSI model. So they're both synonymous when we talk about the network layer. Now, IP, this is a very important protocol because it plays an important role both in routing and a logical addressing. So when we're talking about the network layer, we're talking about packets, and packets travel from one network to another. So in other words, they traverse wide area networks and they traverse the internet because, well, the internet is by far the largest wide area network. So when we're talking about packets, we're talking about sending data across the internet or across multiple different networks from one to another. And in regards to IP, it plays a role in routing because, well, to send data from one network to another, we have to use routing. And also we need to have a logical address. So we're talking about our IP addresses, IP version 4 and IP version 6, which we're going to spend a lot of time talking about later in the course. So specifically, the Internet Protocol specifies the formatting of our IP packets as well as the schema itself. Now, in regards to it, if we take a look down at the diagram down here at the bottom, we see here on the left that we have Ethernet network number 1, and over here on the right, we have Ethernet network number 2. So we'll simply just call this LAN number 1, and we'll call this LAN number 2. Well, here's the thing. When they want to communicate with one and another, they need to use routers and they need to traverse the internet. So they need to communicate with routing protocols and specifically IP packets utilizing IP addressing. So when we talk about IP, its job is to connect different switched networks together. So these LANs are utilizing switches, they are switched networks, and to be able to connect them together so they can communicate, that's the purpose of IP and routers and IP addresses. So when you think about it, the Internet Protocol, it provides end-to-end connectivity from one layer 2 network to another. Now, when I'm talking about layer 2 networks, I'm referring to OSI model layer 2. Even though we're talking about TCP/IP, you're going to notice that I refer to the OSI model a lot because it breaks everything down a bit further. So we're talking about the data link layer, and we're talking specifically about switched networks. So let's go ahead and let's take a look at this a bit further and talk a little more about the Internet Protocol. Alright, so on this slide, we're going to go a bit more in depth and talk about some of the characteristics of the Internet Protocol. So again, looking down at the diagram down here on the bottom, we have two different networks. We have Ethernet Network 1 and we have Ethernet Network 2. So let's say that this PC is going to be PC 1, and then we'll just call this Web Server 2. When PC 1 wants to get access to a website, specifically a website on Web Server 2, it's got to send a request and they got to exchange data back and forth. So in this example, they have to go across the internet. So to do so, they have to use the Internet Protocol combined with routing protocols to do so. And they're going to send packets of data across the internet utilizing the IP protocol, IP addresses, and routing protocols. So when we talk about the IP protocol where we're sending these packets, I want to talk about some characteristics of it. So number 1, the IP protocol, it's connectionless and therefore it's considered unreliable. And I said similar to UDP because UDP is also connectionless, and we're going to talk about TCP and UDP in the next section. So keep this in mind, and I'm actually going to write it down, TCP versus UDP. So if you need something to be connection oriented, if you need it to be reliable, then you utilize TCP. But IP, it's connectionless. It fires off a packet, it forgets about it, and it doesn't care whether it's received or not on the other end. That's the role of TCP or UDP, and we're going to talk about that in the next section. Now, like I said, it fires off a packet and it forgets about it, so each packet is also independent of each other packet. So it doesn't create a connection, so when it sends off a packet, it doesn't associate it with another one, it just fires them and continues to fire them. But if we're utilizing other protocols to set up connections and to reassemble those packets, then that's their role. That's the role of TCP and other protocols, but not the role of IP. Now, also, since we're going to be utilizing routing protocols, and again, we haven't talked about them yet, there are several different ones. If we have multiple different routers and multiple different paths from Ethernet network 1 to Ethernet network 2, well, each packet isn't always going to follow the same exact path to the destination. They're going to utilize the most efficient route. And if we think about the internet is ginormous. As you can imagine, the environment is changing regularly every second. And so the most efficient route 1 second ago may not be the same as the most efficient route now. And so these IP packets are going to utilize these routing protocols to determine the most efficient route. So packet 1 may go one direction and packet 2 may go a different direction. Now, lastly, IP doesn't provide any sort of error recovery or sequencing. And this is actually very important when we're talking about needing a reliable connection. And that's the job of other protocols. That is not the job of IP. So we talk about other protocols such as TCP and UDP, as well as additional other protocols. That's their job. That's not the job of IP. So we can think about IP as the moving truck. And let's see if I can actually draw a moving truck. Think of it as the actual moving truck sending data across the internet. Think of it as that and nothing else, with all these boxes in the back, and all these boxes are IP packets. Its job is to send them across the internet in an efficient manner, but it doesn't worry about setting up a connection. It doesn't worry about making sure they follow the same path. It doesn't check to make sure they were actually received. It doesn't look for any sort of errors. It doesn't look to sequence them. It takes all of those different roles and it puts them off and makes them a responsibility of other different protocols in the TCP/IP protocol suite. So that is the Internet Protocol in a nutshell, our high-level overview. If you have any questions, please let me know. If not, thanks for watching, and I'll see you at the next video. Take care.